about Paychex. This is the marketing slide that we get provided. So we do payroll, HR, retirement, tax, insurance, anything in the human capital management space. We've been a company for about 46 years. We have offices all over the United States, in Germany, Brazil, and in Scandinavia. The coolest fact, at least for me, is that one out of every 12 American public sector employees gets paid by Paychex. So this is a little bit about our environment at Paychex to kind of give everyone a level set of what we're starting with here. For the team that I'm on is an IT operations or the data services team. We have 3 teams: an operations team, which handles the day-to-day tickets, an applications team, which works with our development partners to kind of figure out the best, the best database solutions to come up with, and the platform team, which I'm on, we kind of do a lot of the automation and architecture around the database. We have 3 data centers, 2 different regions. We have 2 data centers in the Rochester, New York area, and then 1 in the Midwest. We have multiple databases and data platforms that we support, 100+ applications. And then from a database footprint, we have about 35,000 databases. A lot of that is inflated because of how SQL Server does databases, if you're familiar. We have about 1,500 VMs, 250 physical hosts, and about 100 Mongo databases. So for some, 100 Mongo databases is not a lot. For some, it is a lot. For us, right now it's just right, and it's continuing to grow. So the first challenge we had is that we're getting more and more requests for MongoDB infrastructure. We started off small with MongoDB. We had 2 small applications, and it kept growing and growing. We started off in our tax area was where we started with it, and then it's grown to different application families since then. The other challenge we had is our build was partially automated. So partially automated for us, it might as well not have been automated because there's still that manual steps, there's still room for human error, and we had human error. And we also wanted to be able to build more, but keep things standard, easy for our operations teams to support, continuously monitored, and in low risk to the company. Not only that, but not only do we have our IT challenges, we also have our business challenges. If our databases go down, people don't get paid, and people tend not to like that. Not only that, since we do taxes, if we don't pay your taxes, you could have Erwin R. Shyster, if you're familiar with old school wrestling, coming after you saying pay your taxes, or worse, the IRS. So very important stuff for our clients, our customers. Additionally, we're the number 2 provider in the United States for payroll. So we're obviously striving to be number 1. So not only do we have to keep pace with the leader, but we want to try, obviously, and overtake them. So being more agile, being able to deploy faster, getting our applications out faster is vitally important to our business. So this is what our build flow looked like when we started this whole process. Our platform, our SAs had the VMs and OS builds partially. They had that automated, but for us, you can see on the bottom lane, almost everything was manual. Laying down the Ops Manager automation agent, creating our replica sets, creating our standard Paychex users and our roles, adding stuff to Ops Manager, setting up backups, creating application users in LDAP or Active Directory, and our database security scan. All that was manual, so very, very ripe for human error. And an end-to-end time could take anywhere from 1 to 2 weeks for a replica set, which when you start off small, okay, it's painful, but you don't truly feel the pain. But when we started to grow more and more, the pain became more evident. It kind of really hit me that we needed to make a change when typically on a week-to-week basis, I would be involved with maybe 1 to 2 conversations about new applications for Mongo. And then it started to be 3 or 4, 5 or 6, and it got to be like 8 or 9 or 10 conversations each week that I was having. So I knew an avalanche of Mongo was coming our way, and that this was going to get really bad really fast if we kept it up like this. So this is the full-out manual process from kind of start to finish. Development would send in a ticket. A database engineer would review the solution architecture with our leads. We'd request a VM from the systems team, and they would provision it, and that's kind of where that manual flow from the previous step would kick in. We would add our users, custom roles, monitoring backups, that good stuff. And the turnaround time, again, 1 to 2 weeks. But probably the worst part was that the MongoDB SME at Paychex, which is me, was involved in just about every build. And that was never going to be sustainable. So here we get to me. I know that usually we do the About Me slides first, but I've been using Mongo for about 4 years, a MongoDB master. I've been involved in the CAB and the Advocacy Hub. I tweet, I blog a little bit, but I don't scale very well, I found out. That became quite evident when we got to the 10 applications at a time. And I was having to go to meeting, and it just, it was never gonna work very well. So that's kind of when we decided to start looking into how do we automate our MongoDB builds? How do we get out of this pain point and kind of make it so I don't have to be involved in every build? So the first thing we tried was putting all of our automation logic in Puppet. Puppet, if you're not familiar, and I'll cover it a little bit more in depth later, is a configuration management tool. It worked okay at first. There was a lot of, what I'll say, decisions we had to make in our automation that when we got to it later, we figured out Puppet wasn't really a good fit for this specific part of the automation. So that was kind of our first go. It worked okay. There was a lot of issues. For example, anytime you got a new version of Mongo, you either had to upgrade every single replica set that was in Puppet, or you would have to make parameters to kind of delineate them, which got very cumbersome very fast. So the next thing that we tried was doing all the automation logic in Ansible. Similarly, we had some early successes with it. It was easier to learn. It was easier to code against. But once again, we were missing the configuration management of Puppet. We could lay down a config file, and we knew what it looked like when we laid it down. But if someone went in there and changed it, there was nothing to kind of go back and check and make sure that that config was still the same. So we're still having configuration drift. So problems still remained even after our 2 different tries. Our upgrades were still manual through this all. We had brittle solutions that were still ripe for human error, even with our automation. All of our integrations to third-party tools were still manual. And actually, the hardest thing to get past was our engineer apathy. We had people saying, well, it's still faster than Oracle builds. That's good enough, right? But we wanted to hold ourselves to a higher standard, obviously. So our solution was to kind of go through and create a MongoDB as a service. However, we still had some challenges that we had to consider. Different applications have different requirements, even different replica set design patterns. And there's no standard way of building a Mongo database as a service outside of Atlas. So now what should we do? So that's when we kind of decided to take the best of the 3 tools that each fit a specific part of our automation. Puppet for our configuration management, Ansible for our third-party integrations, and MongoDB Ops Manager for the whole MongoDB part of it. So once we kind of came up with this workflow, our automation flow becomes vastly different. Obviously, our OS stuff is still automated, but now we can have Puppet lay down, for example, the automation agent, and then we could have Ansible call into Ops Manager to create our replica sets, to install our standard users, add it to Ops Manager, set up backups, create our users in LDAP and Active Directory. The only thing that still remained manual was our DB security scans, and that's just because that third-party tool that we used didn't have any kind of API or anything for us to interact with. So we're still working on that, but that's not really a Mongo problem. Oh, I forgot the best part. So, and I just gave it away, but so we're at 1 to 2 weeks, and since I gave away the good stuff already, we were down to 15 to 25 minutes, depending on the replica set size. So you can imagine how happy our developers were when something that would used to take them a whole 2-week sprint to get, they could request it in the morning and, in theory, have it by the afternoon. That allowed them to innovate a lot better. Allows them to get stuff to market much better and much more quickly. And it kind of removed the bottleneck to a point of me having to be involved with every workflow, because this is something that anyone can kick off without necessarily needing the MongoDB knowledge. So now I'm going to talk about a little bit more in depth into the tools and kind of how we implemented them to get to this. So Puppet, if you're not familiar, it's a configuration management tool. You can manage your systems declaratively with a Ruby-like language. If you're familiar with the term infrastructure as code or codified, this is kind of where we needed to get to as a company and an IT operations org specifically. And this kind of helped us get there. And you can create manifests that can be pushed to many hosts via the declared host group. So this helps us make sure that our config files look the same where they're supposed to across our entire environment. That if we set a parameter and we need a parameter set, it's set everywhere. So when do we at Paychex use Puppet? We use it for our configuration management, making sure Linux services are always up, and then keeping hosts within a group of hosts using the same config. This is very good for us on the OS side as well, setting specific parameters, creating users, OS users that is. Yeah. So what we don't use Puppet for is when orchestration is needed. This is because Puppet doesn't necessarily run things in the order that you have them in the code. There's ways to kind of force that, but it's kind of not what Puppet's really good at. We also found that managing our database RPMs was something we didn't want Puppet to do either, because this, as I mentioned before, was the issue where if you upgraded one, you had to upgrade them all. And Ops Manager was much better at doing that, because we didn't have to put the logic in Puppet to do the upgrades. We could just have Ops Manager do it. So this is the part of the automation flow that I showed earlier that Puppet does. It does the OS config, disables transparent huge pages for us, creates the MongoDB user, and creates our data mounts with the correct permissions. And it also lays down the Ops Manager automation agent. So this is a sample of some of our code that we use in Puppet. This particular code is what creates the MongoDB user and the agent user. So this obviously makes sure that they're created, that they have the user ID and group ID that's consistent across our environment. These aren't the actual user IDs and group IDs. And that they have a home, all their password settings. So it ensures they're consistent, so you don't have a MongoDB user on one server that can read a file that another one can't. And this other example that I have is kind of how we set the file system, how we set up the data with the /data directory, giving it the right permissions, the right owner. And then you see that bottom part where it says require user MongoDB. This is kind of how in Puppet you can force something to happen after another thing. So this is basically telling Puppet, don't run this step until that MongoDB user is created, because obviously you're not going to be able to assign ownership to that data mount if that user doesn't exist yet. So now I'm going to kind of talk about Ansible, which is another piece of the cog. Ansible is automation for everyone. It's DevOps made simple, and it's agentless. So what those mean is that it's very easy to learn, as opposed to Puppet, where you kind of have to basically learn Ruby to be able to kind of get, I'll say, to get good at Puppet with Ansible. It's much more easier. It's much more human readable. And it makes sense to both developers and to operations folks. So it makes that DevOps life much easier for both sides. And the agentless part is just good because then there's no security vulnerabilities to worry about because it just uses a standard SSH, at least in the Linux side. So what do we use Ansible for? We use it when order matters, when we need things to run in a specific order. And when we need a process to occur once and only once. One of our inefficiencies with Puppet is that it would run every 30 minutes. So some steps that you needed only to run once, and then you're realistically were good. Puppet was going through every 30 minutes and checking stuff that we know will never change. And with the mutable server architecture, your spin up, spin down type systems, we're starting to use these in some of our lower environments. So kind of getting our heads wrapped around how that was going to work was very important. And when we needed to integrate with third parties, Ansible was much more friendly with that than Puppet, generally speaking. And of course, whenever we wanted to get rid of a shell script, that was also a great place for us to use Ansible. So the part that Ansible plays in our automation flow looks kind of small. It really only does an API call to Ops Manager right now. But that kind of kicks off the most important part of our workflow, where all the Mongo stuff comes in. So although it's a small part, it's a very important part. So here's some of our Ansible code. This is our main Ansible play that we have. You'll see it includes another Ansible play, the Ops Manager-API. And it basically checks to make sure our Ops Manager API key exists, it is not set to nothing, and that we're running initially on the primary node. And then this is the play that's referenced in the previous playbook. So this basically will go out to Ops Manager, get our standard configuration. Then it takes a template that we have set up, which I'll show in the next slide, kind of puts them together in the replica set design that we passed to it. And then we send that configuration back to Ops Manager to actually build replica sets. Excuse me. And this is the template that we use. The example that I used was a 3-node replica set, but you can kind of see that we're just basically passing in the parameters for each host so that Ops Manager knows which hosts, I should say, to add to the replica set. So that's kind of what Ansible does for us. And then next, I'll go into Ops Manager. So this is the best way to run MongoDB if you're on-premise. For us, we use it for management. It's very much an automation enabler for us, for MongoDB specifically. I wouldn't be up here having this talk if it wasn't for Ops Manager and what it's been able to do for us. So we use it for, obviously, provisioning and upgrades. We use it for monitoring, and we use it for our backups. So it's a very important piece to our MongoDB puzzle. So from the automation workflow, we use it for adding databases, setting up our backups, creating our users and roles, and upgrades. So it kind of solved a lot of the problems that we were having that were Puppet or Ansible by themselves couldn't really handle the Mongo part very well. But Ops Manager handled them brilliantly. So then we had to tie it all together with orchestration. And this is kind of a work in progress, but I'll kind of mention it as well. So we looked at basically two options at the start of our orchestration journey. Ansible Tower by Red Hat, and Atrium Orchestrator, which is a BMC product. We only looked at these two mainly because of previous vendor relationships. And in the end, since it took us so long to kind of make a decision, we actually chose something completely different. Sort of, I'll say. While we were looking at Ansible Tower, and Red Hat open sourced it into a product called AWX. And that's actually what we're going to be using now for orchestration. So that ties in directly with Ansible. So that's going to be great for us. We're starting that in one of our other projects right now. And I'm really looking forward to that, to kind of tie everything together so we can truly have it where a developer puts in a ticket and no one from our data services team even needs to touch it because the automation workflow just happens automatically and it's orchestrated in the way that we need it to be. So these are some of the feature things that we're looking forward to doing. Using Ansible to set up our backups and snapshot schedules in Ops Manager. Right now it does set up the backups. But we're looking to see if we can configure it so that if we have different backup retentions, because we're starting to see that now with more applications, sometimes our backup retentions are now changing. So we want to look into using Ansible to call into Ops Manager to do that as well. Using Ansible to automate our Ops Manager restore jobs. One of our big things that we need to make sure is that our jobs are good. So if we can automate that and have an automated test that shows that they're time, that'll be awesome. And then ServiceNow is our ticketing system of choice. We're looking for integration with that, with AWX, the open source Ansible Tower, OpenShift and OpenStack integration. There's been a lot of good articles out there about MongoDB on OpenShift and OpenStack. So we're kind of we use both of those products, so we're starting to look into see what that might look like. And then public cloud integration. Right now, we have a small presence in Azure for Mongo, and we're kind of looking to see if we can port some of this code to build some of our stuff that's in Azure today. So through all this, these are kind of the main lessons that we learned. And there's actually one I'm going to add as well that I've thought of in the past couple of days. First and foremost is use the right tool or tools for the job. When we tried to squish everything into Puppet, it wasn't work. We were using Puppet for what it was good at and for stuff that it wasn't good at. We were trying to get everything into it. Similar with Ansible. We were using it places where there was a different tool that was better suited for it. There's always room for improvement. You can always be iterative about it. We don't feel like you have to kind of build the whole solution at the start. We found that kind of building things piece by piece and adding on as we go helped us keep better feedback loops with development and other teams and kind of be able to be more agile in how we reacted to it. And then make the process truly DevOps. Involving our development partners early and often was vitally important because we found that stuff that maybe made sense for us as far as how to automate it and how quickly things needed to be maybe didn't match up with what they needed. Maybe if we got to one or 2 days turnaround, we would have thought that was good enough, but for them, obviously we needed better. And the other lesson that I learned that I wanted to share was that work with your MongoDB team. They have a great community, lots of resources, whether it be your sales team or the developer advocates. They've been so very helpful with us on this journey. So don't be afraid to reach out to them. That's one thing I'll say. And then just to summarize it all, automation is an iterative process. Work with your business and development to become a business enabler. That's not always evident to some of us operations folks, but it's becoming clearer and clearer. And then get creative. Even if it's a tool that you maybe don't use at your current job, look and see what might be needed to kind of bring it in if it solves a problem that you have. That's kind of how Ansible came onto our radars. So with that, I am done. And any questions?
Thanks, Mike.
Okay. Thank you.
You were saying you're getting like 8 to 10 new requests every week.
Mm-hmm.
Do you still have to work with some of the teams that have more complicated requests? Like if someone comes in wanting like a 20 terabyte sharded cluster, are you still having to kind of babysit those projects?
To a degree. What we found is some teams who have been using Mongo for a couple of years, they can pretty much go off on their own. They know what they're doing. we can kind of just basically take a glance at the solution architecture and be like, okay, yeah, this makes sense. This is good. So it's one of those things where it kind of comes with time. If it's a new project, or not a new project, if it's a team that's new to Mongo, we'll probably look into it more and make sure they understand more of the nuances, because a lot of them have been coding against Oracle or SQL Server for 15, 20, 30 years. So those are the ones that we kind of find that we have to babysit more and just make sure that they're aware of the differences.
In Ops Manager, so how are you setting up your groups? Are you assigning, one cluster per group per application, multiple clusters? And if so, are you giving access to Ops Manager to your different development teams?
That's a great question. So right now, and we're looking to change this. Right now, we just have one big group with everyone. That kind of came out of the fact that when we started, we had basically one application family using it and smaller applications. As we've grown, what we're likely going to need to do is create a group basically for each application family. We do give developers the ability to have read access into Ops Manager so they can kind of see the performance graph. And again, that comes back to similar to the previous question where they don't have some development groups don't have the familiarity. So kind of giving them that picture into what Mongo is doing, since the tooling around Mongo for them, they might not know what's available out there. So giving them that access is very important.
Thanks, Mike.
Yep.
Quick question. Are new projects going towards cloud or on-prem?
At present, it's mostly on-prem. There's one of our initiatives for one of our applications is starting to slowly move it into Azure. So we're going to probably have some partner applications to that are probably going to go into Azure. At that point, we would likely look at Atlas, though.
How your Ops Manager environment looks like? Do you have only one Ops Manager, or you have maybe one for prod, one for dev?
We have a prod and a test, and that's it. And the prod one we have distributed across our 3 data centers.
Okay, so you have one prod and one dev, right?
Correct.
Okay. So 2 questions. First, in your Ansible playbooks, you specify the key.
Right.
So I assume it's different key for dev and different for prod. How you manage this if you want to create, let's say, a cluster on the development environment or on production environment? And second question, what happens if your Ops Manager will die? Because you have currently, do you have any procedure how to backup Ops Manager or something like this?
Yeah. So first thing I'll say is that our dev environment, we don't really, basically all of our, what I'll say our application databases live in our prod environment, even our non-production databases. So most of our Ansible plays just strictly go against our prod one. But what we would, if that wasn't the case, we would probably just parameterize the API key, and that way we could switch it between the two. And that way someone could pass in either prod or dev for Ops Manager. So that's how we would likely get around that. That way the keys, you don't have to obviously pass in the key into the actual Ansible code. To your other question, we do back up Ops Manager. We back it up basically to, there's 2 parts to Ops Manager. There's obviously the metrics database, which holds the different monitoring automation data, and there's the backup database, which actually holds the backups for all of our other databases. We back them both up, obviously, one being a bit more important than the other. We back them up to net backup through, basically we do the backup to an S3 appliance, and then back up that off.
Hey, with your, you said 8 to 10 new requests a week. I was just curious to know, how are you managing that from like the full automation, where you're kind of taking like the Oprah approach, where you get a replica set, you get a replica set,
right?
Or are you doing some sort of shared way of managing it?
Yeah, that's definitely comes down to partnership with our development teams. There's obviously that shift that's happening now to microservices, where in some cases everyone thinks they should get their own databases. We're trying to temper that so that we don't have 53 gig databases out there serving very similar functions. in one of our applications that has a lot of the smaller apps, we have basically, they each get their own database within a MongoDB replica set, and then they can have their own collections underneath that. So it's basically part of the process when we talk to them and engage with them to kind of understand their needs, understand the data volumes that they're looking for, have those conversations early, and then we can kind of make a recommendation for them if their own replica set would be overkill.
Just a follow-up on like, if someone does get like the replica set full environment for their own, how are you doing anything different for licensing for that?
Let's see, my sales manager's or sales guy's here, so no. Yeah, it's definitely a consideration for us. The way we're licensed now, we have extra capacity for that. So, but it is part of the conversation where if they came telling us that basically they're going to have something that's going to blow out our licensing, we'd want to have that conversation ahead of time so that we can engage with our sales team and kind of get that justified to see, okay, do you really need this? Or are you going to, because one of the other things that we find is they'll quote us saying that they need 512 gig replica set or 512 gig memory replica sets, and we kind of talk through it with them, and they're like, "Yeah, well, really, we're not going to need that till like year 2 or something like that." So we can kind of get away with a smaller replica set they'll start off with.
Ops Manager give you a different group ID for different groups, right?
Correct.
So how do you handle on the Puppet? Like when you do an installation of automation agent,
Mm-hmm.
you have to give a different group IDs for different groups. For example, if you have a dev, QA, and other 2 projects, so everything is a different group ID. So
Yeah, that's a great question. So we use open source Puppet. So there's a tool that we use called Foreman, which kind of holds parameters. So we can kind of set what are called facts about the servers. So it's, for example, we can say this server is a dev server for this application, which then Puppet will take that and say, okay, if that fact is set to that value, then I know my group ID is this. So that's been wonderful as well.
So, like through Ops Manager, if I am changing any configuration, like
Mm-hmm.
I'm enabling profiler and everything, so it's going to update everything on the automation agent.config file. So will the Puppet going to monitor that and it's going to revert the process, or how do you?
Yeah, we don't, for that exact reason, we don't have Puppet actually control we have it laid down, the initial configuration file, but that's one of those where I mentioned that we only need it to happen once. So basically, we'll have Puppet lay it down once and then not really check it again. For that very reason, because if we enable profiling or if if for whatever reason we had to turn off TLS or SSL, we wouldn't want Puppet to go in and overwrite it. So.
I have 2 questions. So you mentioned that you have a multiple data center and on different regions.
Mm-hmm.
So do you have a replica, nodes across the region, and also it's a data bearing node?
Yeah. So for most of our applications, we have it distributed between the 3 data centers. Since we're Rochester heavy, Rochester is 2 of our data centers. So if we're distributing reads, we'll probably distribute the replica sets in that way. So some of our applications are more read heavy, so we'll have 2 replica sets in each data center there, and then 1 into the DR data center. For some of the other applications where we want automatic failover, we'll have 1 in each of the Rochester data centers, 2 in the DR data center, and then we'll have an arbiter in Azure. That way we can survive regional outages on either side.
Okay, so second one. What about the reader preference? Are your application majority reader preference is still primary or second?
It's going to depend on the application. So for example, one of our newer applications is very read heavy. So what we're going to set for the read preference there is that it can read from any, basically we'll probably use tags to tag them by data center and make sure that it only reads out of the Rochester, the local data centers where the application servers live. Will be the preference.
Okay, thanks.
Your information, can you shed some more light on the storage allocation? Is it part of the same process or a different one?
The storage, how that gets set up? That's more of the SA stuff. So we basically have a standard config from a storage perspective of what we request. That's part of what we request when we send the request to our SAs. We'll say, we'll need maybe 200 gig for the database storage, and then maybe 50 gig for the logs.
It's part of the same automation?
It is. The storage itself, provisioning the storage is not automated at present, but our SAs are able to request it automatically, but it doesn't get provisioned automatically today.
Hello.
Hello.
How do you manage your MongoDB versioning? How many versions do you let people provision from your orchestration tool?
Yeah, so that once we kind of let this loose, it's going to kind of get interesting, I'll say. For right now, we've only got people on 3.4 and 3.6, so it's not too bad. A lot of it, as probably most of you are aware, is driver dependent. So most of the drivers by now obviously support 3.6. We're going to have some applications that are going to want to go on 4.0. So depending, a lot of our stuff uses Spring Boot for Java. So we're going to have to, and I know they're partnering, so they should have a 4.0 driver probably relatively soon.
From the minor version upgrading, is that something that happens automatically, or how do you coordinate that with so many applications, on the floor?
So that we've actually partnered with our SA partners. After all the Spectre meltdown stuff, they kind of instituted a quarterly patching cycle. So we've been able to kind of roll our patching into that. So we'll do minor version upgrades every quarter, because typically that doesn't require driver upgrades for us. So it's pretty low impact.
One last question. With regards to the automation agent, meaning I saw that you have many MongoDB hosts running on the floor, VMs and physical.
Right.
So every host requires an automation agent. Right?
That's correct.
So if you have hundreds of automation agents running, were there any administrative challenges that you kind of ran into? And second question to that is, second part, any overhead on the ops manager as a result? Thank you.
There hasn't been any, on the automation agent side, there hasn't been really any impact for that from us. Ops manager's been able to keep up. I mean, we have seen, for example, since we started versus, we also load balance our ops manager, so we're able to use all three of our ops manager application instances to kind of handle the traffic. So we've seen slight increases in CPU and memory usage, but it's been very sustainable. It's been able to keep up very easily. Okay.
So who is pushing that button that gets in the Mongo database? Is it still the end user? Is it a self-service type, or is it still your team?
For right now, it's still our team. We want to get, when we get that integration with our ticketing system, then it'll kind of be touchless, which is where we want to be. We want to get ourselves out of that process completely, but today it is still our team.
Okay. And for the operational support, is it, they build it, is it the DevOps where they own the maintenance piece also, or is it still your team who provide that 24/7 support?
So most of the actual builds happen by the application team that works with, the application DBA team that works with the developers directly. They'll do the builds, and then the way it's supposed to work is that they'll do a kind of a handoff to our operations team, so that the operations team understands what this database is and what application and all that stuff.
Okay, thank you.
Mike, thank you very much.
Thanks.